All right, how did the homework go? Any questions for me? All right. So today is kind of the opposite, the reverse of what we've been doing. Before, we've been told that we have a parallelogram and we have the properties that we know are true. So today is backwards. We're looking at a four-sided polygon and deciding if we have enough information to say it's a parallelogram. All right. So I equate it to, when the Weather Channel or the Weather Service says the conditions are right for a tornado. That's different than they're being like, oh, look out the window, there's a tornado. Do you agree? Like, one, I can see it. One, just the conditions are right. It's, cold front, warm front, whatever, maybe some high winds, but there really isn't one yet. Right? The conditions might be right, but all the conditions have to be met to make it one. So on one hand, we know there it is. I can see it. That was yesterday's lesson. Today, you're looking at a four-sided polygon and determining if there's enough information. All right. So you guys wrote down some of them. And I apologize. I forgot the new book, for whatever reason, doesn't include the fourth one. So we'll write that one down, right?
Do you have an extra guided notes? I kind of put them in the wrong order.
Yeah. All right. All right, so we're going to go through these together. They might be a little out of order. That's all right. You guys can figure them out. All right. This one, is it a parallelogram yet? No. But if you see a quadrilateral with one pair of opposite sides that have to be both congruent and parallel, then it has to be a parallelogram. All right? But those opposite sides need to be congruent and parallel. Next, if you look at a four-sided polygon and the diagonals cut each other in half, has to be a parallelogram. If you look at a quadrilateral and it has two sets of opposite sides that are congruent, has to be a parallelogram. If you look at a quadrilateral and has two sets of opposite angles congruent, has to be a parallelogram. And the one that a lot of people did not fill in because it wasn't in this book is if a quadrilateral has an angle supplementary to both, I'm going to put that in all caps, both of its consecutive angles, then the quadrilateral is a parallelogram. Was this number 4 for you? And I believe they used x and 180 minus x. For the picture. And I bet it doesn't take too much for you guys to realize that this angle being supplementary to this angle makes these parallel. This angle being supplementary to this angle makes these ones parallel. And so the condition has been met. It must be a parallelogram. Can you see that? Okay.
Oh, what's the name of the
It's kind of a long one. It's one angle supplementary to both consecutive angles. This one?
Yeah.
One angle supplementary to both consecutive angles. All right, and then we're going to need to make another adjustment on your guided notes. There's just one word that needs changed. On the first example, this is your first example, right? The proof. We're going to change that word quadrilateral to parallelogram. All right, we're given that. All right, do you see where we're going to head with this? What do we need to get to? We need to get to one of the... Yep. And let's call them conditions, all right? Let's call them... I know they're theorems, so I agree with that. Let's call them conditions. I think if you guys, in general terms, if a condition is met, if you meet your parents' conditions, if you clean your room, you can go to the movies. Okay, did you meet the condition? Yeah, you can go to the movies, right? If it meets a condition, it gets to be a parallelogram. So, how are we going to get there? Well, I bet when you see triangles, you're thinking if I could show the triangles are congruent, and then I can get to, now, by the way, we can't use the opposite sides one, because that was all given to us to be the world's most boring proof, all right? And I even gave you a hint. We are proving that opposite sides are parallel, okay? So we're using the definition. And to be honest, I would have to tell you that if it's on a quiz, because you'd be like, hey, I thought I could just use opposite sides are congruent. I'd be done. All's good. Well, if you're asked to show it in a certain way, show that these are parallel, then how can we show parallel in a picture like this? How can we show a pair of sides are parallel? We learned a lot of theorems that had to do with if blank is true, then the lines must be parallel. Remember those? Jackson. Yeah. So I'm looking at these ones, and I'm not saying they're congruent right now. I'm just pointing them out to you. Don't mark them on the picture yet. I don't know that these angles are congruent. Don't mark them on the picture yet. Do you agree those angles are called alternate interior? Yes? Are alternate interior angles always congruent? No, only if the lines are parallel, right? What else is true, though? If you do some work and, oh, look, those angles are congruent some other way, not because they're alternate interior, some other way. Oh, those angles that are congruent are alternate interior angles. BC and DA must be parallel. Oh, that's the converse of the alternate interior angles theorem, right? So how can we get to the point where we can show those are congruent? Well, probably CPCTC, right? So let's do that. I don't know that those are congruent yet. But with the reflexive property, I do know that AC is congruent to CA. And so triangle ABC is congruent to triangle. What would the correct order be? ABC, and then what did you say? CDA? Is that what you said, Olivia? Yeah. CDA. By which of the five? SSS. And then you get to pinpoint which one you want to use CPCTC on. So we looked at these ones first. Angle BCA congruent to angle DAC. Not because of alternate interior, because of CPCTC. Does that make sense to you? I know that's a challenging concept because we've seen it both ways. Does it make sense that it's because of CPCTC, not because of ultra interior, right? All right. Well, that's going to make BC and DA parallel, right? Aren't we going to have to show both sets of opposite sides are parallel? Well, are these alternate interior angles congruent? Now, when I say alternate interior, not because of alternate interior, but because of location, are these angles congruent? Not because of alternate interior angles, CPCTC. So I'm going to put it on the same line because they have the same reason. So BAC DCA still by CPCTC. Which makes BC, this thing's going to glitch out on me, so excuse my writing. BC parallel to DA. And AB parallel to CD. By what's the reason for that step? Got this. Callie?
Is it the converse of the alternate interior angles?
Yep. You can write it out. I have to abbreviate it since the whiteboard, smartboard, whatever it's called, is not cooperating. So alternate interior angles theorem, AIAT. Well, we said the parallel. We said this side's parallel to this side, and this side's parallel to this side. So the shape ABCD is a parallelogram. Reason? Well, that's the definition. Definition of a parallelogram. And you're responsible for understanding that the definition of a parallelogram is it has two sets of sides that are parallel. Two sets of sides that are parallel. So that's the definition. Then there's properties. And then today, conditions. Does that make sense? Okay.
So you're not given that it's a parallelogram. Like, do you usually just have to prove that it's a triangle? Like the triangles are congruent first? Or?
Yeah, 9 times out of 10, if you're going to prove something with these, it's going to have to do with congruent triangles, because that's just the only. Like, if you think of tools in a toolbox, we don't have very many tools right now, in the grand scheme of things. That's our only way to get there, is congruent triangles and then CPCTC. There's going to be other ways. And actually, yesterday, you guys, not proving that they're parallelograms, but proving those. Remember that 2 parallelograms that were point to point with the vertical angles we did in transitive property? That was a little different. I mean, we did angles were congruent using the transitive property, but a lot of times, if there's triangles within the picture, you're probably going to use congruent triangles. There's another question. You good? All right. Is KLMJ a parallelogram? Say we don't know. We don't know. All right. Now then it says find values of A and B that will make it a parallelogram. Is this at the top of the back view?
Yeah.
Well, if I see this side has B's in it, this side has B's in it, A's and A's, it probably makes sense if we're going to set them equal and see what value of B would make them equal, right? find B, find A, and that would be the only values that would make this a parallelogram. So we're going to set them equal. So 5B plus 6 equals 8B minus 21. We go through this quickly. Subtract 5B from both sides. Add 21. And divide by 3. Now, it didn't tell me to find the side lengths, but I wanted to be confident that if I plugged in B equals 9, that it's going to make those opposite sides congruent. And I can see that both sides are going to be 51 when B is 9. Next, we got to deal with the A's. 15A minus 11 equals 10A plus 4. Subtract 10A from both sides. I'm getting A equals 3. So we got 34 here. And 34 there. So I would say for my answer, A is 3 and B is 9. Those are the values of A and B. That would make it a parallelogram. Okay? If A or B are any other values, it's just a four-sided polygon. All right, next one. Next one, it trips some students up sometimes because it has X's and Y's in it, and it has to do with angles. So when you guys see problems like this, you should be in your mind, you should know these conditions and properties well enough that you can narrow it down in your mind to say, oh yeah, that has angles. I know some conditions for parallelograms that deal with angles. One of them is opposite angles are congruent. Let's try that one. Well, can I set 6y plus 7 equal to 8y minus 6? Yeah, they both have y's. I could solve for y. Now pause for a second. What's the other condition that has to do with angles? One angle is, Levi?
The S angle is supplementary with R.
Good. And R is supplementary with Q. So could I add up R and Q to equal 180? I could, but do you see how this has an X and this has a Y and I wouldn't get a value? What about R and S? They have X's and Y's. They're different, right? So even though I know a couple conditions that have to do with angles, which one's the better one? Set the opposite angles congruent in this one. Do you agree? All right. And let's solve for Y that way. And we may have to solve for X in the other way, and using another condition. All right, subtract 6y from both sides. Did you get 6.5? So at this point, I'd plug in 6.5. 6 times 6.5 is 39, plus 7 is 46. Double check my mental math. And 6.5, let's see, 48, and 4 is 52, 52. Wait a minute. 48. 4 is 52, minus 6. Yep, 46. There's a couple ways we can find X. Is everybody okay with solving for Y on that one? Okay. There's a couple ways we could find X. One option is knowing what this angle right here is going to be and setting 15x minus 16 equal to that angle. Do we know what this angle in blue, the angle R, is going to be? If it's going to be a parallelogram, it has to be Go ahead.
Supplementary.
Yeah, so it's got to be what?
134.
134, doesn't it? If it's going to be a parallelogram, this angle has to be 134 degrees. So 15x minus 16 has to equal 134. Option 2, you could say 15x minus 16 plus 46 equals 180. You could add up the consecutive angles to equal 180. Does that make sense? Both options are correct. So 15x, I'll do this one, it's a little shorter. 15x equals what, 150? So x is 10. And again, I knew the angle was 134, but that's not what it asked me. It asked me to solve for x and y. So I had to go ahead and solve for x in that situation. All right. Again, we're looking at this quadrilateral. We don't know if it's a parallelogram yet. This one's a little tricky because I think through the conditions and I see one pair of sides that are given that I know need to be equal. What are these angles? Are these opposite angles or consecutive angles? Consecutive. So they're going to need to be
180.
supplementary. Yep, add up to equal 180. So let's start with the sides. 7a equals 2a plus 12. We get 5a equals 12. We get a is 2.4 is what I'm getting. And you guys told me that these angles 10b minus 16 and 9b plus 25 need to add up to equal 180 degrees. (10b) and 9b make 19b. Negative 16 plus 25 is 9. So 19b equals 171. Divide by 19. 9. Thanks. Now, I don't know if you guys see it or not. What condition would that mean? Because I don't have both sets of opposite sides congruent. I don't have both sets of opposite angles congruent. And what's that one about the supplementary? One angle has to be supplementary to both consecutive angles. That's not an option. I can't just make this angle whatever I want down here. Well, let's go ahead and plug in the values and see what the side lengths are. All right. 7 times 2.4, 14, 2.8, was 16.8. Is that right?
Mm-hmm.
And 4, and then 0.8, 16.8. Yep. All right, now we'll plug in 9 for B. We get 90 minus 16. You get 74. 74 degrees and 106 degrees. Has a condition been met?
Mm-hmm.
What do you guys think? Who votes yes, a condition has been met? Who votes no, a condition has not been met? Who votes? A condition has not been met yet, but it could be. All right, good answer. What do you think? Opposite angles are out because I don't know anything about these two angles down here. Do you agree? Consecutive angles being supplementary. Well, I have a pair of consecutive angles supplementary, but this angle has to be supplementary to both, or this one has to be supplementary to both. And I don't have any information about these two angles down here. That's out. There's no diagonals at all in the picture, right? There's no diagonals. You can't go off of that one. What's left?
Parallel to
One set of sides that are
congruent and parallel.
congruent and parallel. I have one set of sides that are congruent. Are those sides also parallel? Don't know yet, but we need to tap into way back when converses of stuff. If consecutive interior angles are not congruent, supplementary, then the lines forming them must be parallel. That's an arrow. Now do we have a pair of sides congruent and parallel? Yes. That one's tricky, wasn't it? Do you see it or not? No, still don't see it. See it? All right, well, here it's obvious. I see a pair of diagonals. And if those diagonals are going to cut each other in half, n would need to be the midpoint, which means these two segments need to be congruent. Go ahead and solve this one on your own. Did you get 9? Hold on. Wait, no, 28. 2x equals 28. So 14?
I was scared.
I added 1 instead of, in my mind, I saw a 1 there instead of an 11. All right, x equals 14. It didn't ask us to find the segments, but if you did, you can plug that in and solve for it, or figure out what CN and EN are. All right, we good with those conditions? All right, now these ones tend to be really tough for students. Here's what I will say. Take some time each night, and I can hear some of you saying, I'm not doing that. All right, but if you want to do well on the quiz and you don't want this section to wreck you, all right, I'm being honest. If you don't want this section in the quiz to just hurt your grade because it's really no partial credit. I mean, it's either right or wrong. You have to know the conditions and properties. They're not that hard, okay? They're very similar to each other. Some are a little different, but when you look at a picture like this, you have to recognize it has a condition been met or not, right? And you have to know them well enough to be able to do that. For example, if I covered up this 107, I only have one pair of consecutive angles supplementary, right? But what does the condition say? One angle is supplementary to both. Okay, a condition has been met. Yes. One angle. Okay, supplementary to both. You can't just say both. You have to say both consecutive angles. Next one's a little tough. I see one pair of opposite angles congruent. Do you agree? But then I see part of another pair of opposite angles congruent. That's not one of them. So then I'm starting to think, oh, well, those are alternate interior. They're congruent. That would make these parallel. Maybe that's it. I see a reflexive property. And the kind of you asked earlier, about proving it's a parallelogram. Like, yeah, a lot of times you're going to see triangles. Is there a way we could use the triangles? Well, don't write out. This is not a proof. Don't write it out. But do you at least see the reflexive property? Are these triangles congruent? By A, and the S that's not between them. This is not ASA. This is AAS. Do you see it? Are these triangles congruent? Well, yeah, then it's just a free-for-all. Like everything else, CPCTC. Everything else has to be congruent. So yeah, I mean, this thing would be met by any condition pretty much, right? Except for maybe the one angle supplementary, both consecutive angles. We just don't know that they're supplementary. Do you see it? Okay. So you could list any property you wanted there. Just to kind of go back, I think the least amount of work might be, we didn't do third angles there much. Probably the least amount of work would be the AAS, and then your CPCTC, and then now you wouldn't have to say the angle addition postulate, but do you see how a double tick mark and a triple tick mark are going to add up to the same double and triple over here? So opposite angles are congruent, okay? So you could say quadrilateral with both sets of opposite angles congruent makes it a parallelogram. Have I used this arrow notation before? Implies that? I think I have. It was back when we did. Did I use that?
Yeah.
You remember it? I forget when it was though. I'm having a brain lapse. I apologize. But the arrow, this is just shorthand. Angles congruent makes it a parallelogram. Implies that it's a parallelogram. Again, you could have done other ones there too. You could have done alternate interior, parallel, and then use the definition. Say by definition. That's fine too. Last one. Parallelogram or not? No, not enough information. But it says that a pair of opposite angles are congruent. I thought that was one of them. No, it says both pairs of opposite angles congruent, right? All right. I'm going to run out of time, but you're going to be responsible for this because it's not that bad. If you graph 4 points and you're asked to show that it's a parallelogram by using the definition, what's the definition? Both sets of opposite sides are parallel. It's on a graph. How do you show parallel on a graph? Slopes. Rise over run. Watch up here. Show that these ones have the same slope and these ones have the same slope. Okay? So when you note this, you're going to say like the slope of JK is blank. The slope of KL is blank. Just count. Rise over run. If you want to use the slope formula, y2 minus y1 over x2 minus x1, you can. Okay? And then in your book, you got the shorthand version of 4 of the 5. Okay? This one's the definition. This was not in your guided notes. This was on a couple days ago. All right. So these 4 plus the one that I added that had to do with consecutive angles being supplementary. This is the shorthand version of those conditions. It's also in the book. You don't have to write it down again. You have it in your guided notes from last night that you wrote for homework. Does everybody understand how to show that it's a parallelogram by definition, by graphing it? Yeah? All right. All right, homework for tonight. We do have our Friday's kind of like a bit of a day off for you guys. You have that quarterly checkpoint. It's really not a high pressure test. But you're gonna bring in your laptops. Won't be any homework, so it'll be kind of a nice day for you. It's not gonna be too rough. Early next week, we'll have a quiz review and then a quiz on the parallelogram stuff.